All right, CNT120, we're working on Chapter 3. We have our last piece here of IP version 4 addresses. We just got done talking about classes and subnet masks, and before they leave this section, they say, okay, there's a couple other special IP version 4 addresses we need to be aware of. Now, when we deal with 8 bits, of binary, we actually have 256 combinations from 0 the whole way up to 255. 0 counts and 255 counts. So that gives you 256 combinations. Well, in reality, what I find out is nodes really only use 1 to 254 because 0 is set aside to identify the network. Okay? And 255 is set aside to identify or be used for a broadcast transmission. Well, let's make some sense of this. If I have an IP address 192.168.10.53, that is actually a node IP address. That is an IP address for a device on my network, whether it be a computer, a server, a printer, IP phone, IP camera, some kind of node on my network. And that's really like saying 123 Main Street, Mechanicsburg, PA 17055. That is identifying a real thing in the world, okay? If I want to identify the network that that node belongs to, I actually say I take that host portion and make it 0 and say it belongs to the 192.168.10.0 network. That identifies the whole network as opposed to the 192.168.20.0 network. That's a different network. So if I want to refer to the network that that node belongs to, I say 192.168.10.0 network. Well, because I do it that way, I can't assign that to a node because that's identifying the whole network. Example, that's like talking about Main Street, Mechanicsburg, PA, as opposed to Main Street in Hershey, PA, or Main Street in Lancaster, PA, or Main Street in York, PA, or Main Street in Gettysburg, PA, okay? Main Street, Mechanicsburg, PA. So this 0 here, 192.168.10.0, is identifying the network for that node. Last but not least, 255, 192.168.10.255, that is a special address that gets used to send a broadcast to everybody on the 192.168.10.0 network. That gets used to send a message to everybody on that network. Hey, the server is going down. Hey, I'm looking for blah IP. Does anybody have it? That would be a way to send a message to everybody on that network. So again, that number does not get used for a node. It gets used to identify a message that everybody will pick up and listen to. That would be like sending a message to all Mechanicsburg, PA residents. Hey, there's a fair on blah day. Don't forget to don't park on the street kind of thing. Okay, so when they talk about those special addresses, 0 is the network used to identify the network. 255 is set aside for broadcast. Very true. Very, very true. You'll find out later there's a couple exceptions to that rule, but that's basically the gist. That is basically the gist. There's a couple other set aside, and they mentioned the 0000 that's currently not used for anything. And 255, 255, 255, 255 is a broadcast message to everybody. Okay, broadcast message to everybody. 127.0.0.1 is the loopback on my machine. That is a check to see if TCP/IP is installed and running on my system. So if I ping a 127.0.0.1, that's really kind of pinging myself, making sure that TCP/IP is installed, running, my NIC is working, all that happy jazz on my machine. My data really hasn't gone anywhere. It's just making sure is everything on my machine working okay. And this also works on Linux and Mac computers too, because this is a TCP/IP thing, not a Windows, Linux, Apple thing. Okay, this is a TCP/IP thing. So again, that's a check to see if TCP/IP is installed and running on this particular node as well. That doesn't get assigned to anything. That is used for testing purposes. Last but not least, we mentioned the 169.254. That is an APIA address. You normally never want to see this, because it's normally never used for anything, but it's a clue for you if your machine is set for dynamic, get an IP address dynamically from a DHCP server, and it cannot find one for various reasons, it's going to self-assign a 169.254. And that's a clue to dig in and start checking for connectivity issues or network card issues or patch cable issues or something like that to figure out what is going on here. This was, I think, one of the charts out of the book showing you all those. Next, they mention also that there is private and public IP addresses. We talked about Class A, B, and C are licensed IP addresses available for use on the internet. These are called public IP addresses. Public IP addresses. So literally a 10.50.30.20 could be connected out to the internet and connect to, I should say, a 20.50.30.20. Connected out to the internet and out across and so forth. A company can use private addresses on its private network. And that is used internally. It's not going to get routed out across the public network, but my network inside can use these numbers. And what that allows me to do is just this. Let me jump here real quick. If I have my ISP gives me a single IP address, my router and or equipment that I have could translate that into a private IP scheme in here, allowing me to have a number of IP addresses to use inside my network. Well, your router and your router device at home does this. Mine does it at home. The router we use at our church does this. This is a relatively normal function. You might get one IP address from your Verizon, Comcast provider. Your router translates and gives you a little block of numbers to use inside. Well, these are actually private IP addresses. You're allowed to do this. This is legit. This is on the up and up. But it's a normal thing that most of us do. So let me back up real quick now and look at, we get a public IP address from our provider, our service provider, that's going to route my data out through and out to the internet. Oops. I knocked over my water bottle. But inside my network, I have private IP addresses that I'm allowed to use. I don't need special permission to do that. Well, that's because these were set aside for that purpose. IEEE set aside these numbers and recommended the use of these for inside my network private use. I can use a 10 network. I can use a 172.16 network. I can use a 192.168 network. Now, once you see those numbers, you start realizing, oh yeah, that's what I have at home. Oh yeah, that's what I use here. Yeah, this is done on purpose. These are numbers set aside for this purpose. So most people have these at home. Most people have these at places of business, so they can do exactly what we're talking about. They can do this right here. ISP gives them an IP, they translate and use a block of IPs inside. So here more specifically is the private IP addresses used. The 10 network, subnet mask of 255.0.0.0. 172 network, subnet mask 255.240.0.0, and the 192.168 subnet mask 255.255.0.0, allowing you to have a block of numbers to use inside. And my device here, my internet device here, my gateway device here, my router device here will translate these private IPs inside into a public IP that my service provider understands. That leads us to address translation, because that's exactly what's happening. This router here is doing address translation to translate my private IPs into my public IP. So network address translation is a technique designed to translate my private IP addresses inside my network with a public IP address that's routable on the internet. That's what it's designed to do right here, just like that. And again, my router at home does this, your router at home does this, the router at my church does this, on and on and on. Okay, very, very common. Well, there is a couple different ways of doing this. There is port address translation, where we use different ports. Okay, all these nodes inside are using a Class A. 10.11.120, 10.11.121, 10.11.122, 10.11.123. All of these are private IP addresses inside from the Class A range. They're going to connect to the gateway router, and the gateway router is going to translate them all to this 92.52.44.1. They're all going to get converted to that IP. Well, there needs to be some way to keep these sorted. So what happens is the router itself keeps a table and says, okay, this IP address inside is going to get translated this IP address outside, and we're going to use the TCP port number of 8000 to keep track of this node. 8001 to keep track of this node, 8002 to keep track of this node, 8003 to keep track of this node. So anything coming back to this IP 8003, it knows is this IP inside, it'll pass it to that IP, and so forth. So it's using different port numbers to sort these out and keep these sorted out. Very, very common. That's what a lot of our devices at home do. There's also static network address translation and dynamic address translation. And what they try to show you here, I think this is the figure in the book, these sometimes get used when you're sending traffic out to the internet and then returning back. That's not uncommon to run in this as well. Static and dynamic address translation. The big picture here is, remember what I showed you back here. This is very common to have a private IP scheme inside. The router is going to translate into a public IP scheme or a public IP that my provider gave me so my traffic can be routed out across into the internet. Very, very, very common using these private IP addresses. So when you start seeing these, you should recognize, oh, okay, private IP scheme, we're using NAT, blah, blah, blah. So now when I come back here and look at my college IP here, or excuse me, the IP on my machine connected to the college network, what I see is, look at that, 172.23. This is a private IP scheme. Absolutely, the college is doing this. You're doing it at home, etc. Very, very common. And then eventually I'll trace it through and find the college router, the college gateway devices translating this for me. Absolutely. Okay? When I come back in the next podcast, we're going to change gears to IP version 6.